evening, everybody. As Piotr introduced me, my name is Demi. I'm currently the VP of a startup company that I founded with two other partners. It's called Panorays. We're in the field of big data and cybersecurity, but actually I'm not going to talk about what I'm doing right now at all. I'm going to talk about our experience in my previous company that is called Windward. It's a maritime analytics company, sort of like a big data maritime analytics company. And it's more of a use case storytelling. And how we got to where we got to, and which tools we've used, and why we've made our decisions according to the problems that we've encountered. And so I'll tell you a bit about background about myself, but at first I want to know like the division between developers and ops people here. How many are developers? Okay, and ops people? Ops, DevOps? Something? No, okay, interesting. And most of you are using Cassandra in production, trying Cassandra. How many are using in production? Oh, okay. And other people just want to hear about Cassandra? Awesome. This will be a great telling story. Yeah, so at first I will tell about myself a bit. I'm a BSc, I have a BSc in computer science from the Academic College of Tel Aviv Yafo. I'm from Israel, by the way, if I didn't mention. I'm the co-founder of a big data community that I founded with another partner in Israel. And we do most of big data technologies, DevOps, and data science. In the past, I was a senior data engineer at Windward, and I was around beforehand 8 years in the Air Force. I was a team leader and a senior software engineer in the missile defense system. And probably I love technology. All sorts of technology, not only big data technologies, even front-end, software development. It's my hobby as well as my day job. A bit about the agenda. We will talk about our data flow in MongoDB and how we started off. I will tell you a bit about the company. I will tell you about the problems that we've encountered, the solutions that we've implemented, and many lessons learned of the newbies that want to start off with Cassandra, and eventually conclusions. Don't be afraid to ask questions, okay? Just interrupt me and we'll have a discussion. It's much more productive than actually me talking really, really fast and you just watching me and not asking anything. And I do talk fast. Okay, so what Windward does, again, it's a maritime analytics company. Basically, it's ships, okay? We've covered how ships move in the world. It's based on a protocol called AIS. Automatic Identification System. Wow, it's really hard to say it. And I can take the big data spectrum, the big data world spectrum, and divide it into two main focuses. One is like over market trends, where we do like really big batch analytics, and we want to know where things move in the world. Let's say, what is one of the most important resources we have as humans, and not air and water? It's some kind of black gold. Okay, oil. Most of the people are really want to know where oil moves in the world and how it affects our economy. Okay, this is like things from market trends, commodities. Something that I discovered when I came to Windward. More than 95% of all of our commodities in the world move overseas. Okay, it's a lot. Not in planes, not in anything. So once you know many things, many information over market trends, you have a lot of data that you can gain financial benefits from it. And you have the other spectrum, the single data point spectrum, the anomaly detection part, where you want to know which ships or which people in the world are making bad things. Okay, stealing things in mid-water, pirates, sometimes illegal fishing, okay? And this is like more pattern recognition and knowing which are the problematic things from all of the data set. So most of the companies do one of them. Windward did both of them and still does. A bit about the structure of the data and what kind of data are we handling with. Mostly it's data from satellites, okay? It's what you might call IoT data, but it's sensor data. And it's geospatial data because you have locations over everything. And you have many metadata over that data. Let's say this is a location of some kind of object in the sea, and you have many like physical properties over that message. Okay, you have sometimes some kind of identification over that geolocation that you got, and sometimes you don't have anything. You just say I'm here, I'm something. And the data is arriving over time. Yes.
So what kind of devices provide this data?
What kind of again?
What kind of sensors provide?
Okay, what kind of sensors? First of all, most of the, okay, I will talk about the protocol and we'll explain about what kind of sensors actually transmitted. AIS is VHF protocol, it's radio, okay? Eventually you have the world that is round, and after around like 30 nautical miles, you lose that protocol's way of communication, because it just doesn't get anything. But the thing is that I think sometime in the 70s, they put a VHF controller over a satellite, and it got the transmissions further away than 30 nautical miles. So once you have some kind of data that somebody can sell, somebody sold it. And you have providers that sell that data. Okay, you as a person can buy the data as well. But the thing is that it costs a lot. Okay, you can buy it, I think, in a single area of the world, but if you want to buy it over all of the world, it costs a lot. But Windward buys that all over the world and then like reuses the data, because you have customers from all around the world. So you can reuse the data. So satellites get that, okay? And satellites transmit it into coastal locations as well. And we buy that data. Some data comes streaming, some data comes like via polling. It sits on a server and you poll it via FTP. It really depends. And you have many static data that you buy as well. Okay? Okay. Again, it's time series data. Everything is timestamped and time matters. Okay? And because of that, you have some kind of latency sometimes, because maybe the data provider is just out. Okay, his servers are down, but eventually he will give you the data. Because it's ships, latency problems are not that bad. But still, if you get a transmission 12 hours late, it might screw up your calculations. Okay, so maybe latency of a few seconds won't do anything because your batch jobs take like 10 minutes, but more than that would be problematic. Okay, and most of the data is encoded just to save up the bandwidth. It's not encoded for security reasons, but it's like a binary protocol. And as I said, it might arrive late. And this introduces a world of problems to handle. So let's talk about something more graphical and not only words. You have external data sources and satellite information that brings all of the data. By the way, how many of you are using Amazon or any cloud-based provider? Okay, most of the other people are in local data centers or different cloud provider. Okay, awesome. So if you don't know anything about something I say about Amazon, just ask. S3 is like an NFS on Amazon. It's a KeyValueStore, which you can put files in it. And most of our data was sequential over time. So we put it parsed after we computed things, parsed the messages, and put everything on S3 in a time series manner. Apache Spark, how many of you know it? And using it in production?
Yes.
Great. This introduces lots of different kind of problems, but yeah. And we did our entity resolution layer with Apache Spark. Of course, we started off using and saving it in some kind of different kinds of persistency layers. And you can see Cassandra, MongoDB, S3. We've actually used MySQL as well, yeah.
Do you use Spark streaming or just Spark?
Okay. The question was, do we use Spark streaming or just Spark batch jobs? At first, we considered using Spark streaming, but our data is not really streaming. Okay, we take it as batches and organize it in time series manner. But it's not like I'm getting some messages from a queue. I just go to a certain provider and get a bulk of data. Okay, I can stream it to a Spark streaming job, but it just didn't give us the benefit, and we didn't want to use and overcomplicate things. Afterwards, okay, I'm sorry, this is not maps, it's layers. This is the best analogy I could find of a picture of layers. And after we formed our analytics layers with our data pipeline, we had logical structured layers. The first layer was the raw data layer that we've actually stored in S3. A layer above was a more logical layer of entity resolution. Like we've discovered from the messages which ones are ships, actual ships that move, and we've like categorized them with I don't know, like kinds of ships. Okay. And then built behavior over it, and more behaviors and more metadata that we've created over the ships. And then we divided it into the two main worlds that I've defined of the big data, the market trends, and the anomaly detection. Just a question. Who do you think uses the anomaly detection things? Which kinds of agencies or companies might use it? Okay. Sort of, yeah, like let's say military, okay, or like secret agencies or whatever. They might use it because what's important for them are customs, let's say, for illegal fishing and for stealing things. This is what interests them because they want to know who's the problematic one, who's the single data point that is problematic. But the market trends thing, almost everybody, okay, almost it interests even finance, hedge funds, investors, shipping companies, okay? Shipping companies have their own data, but they want metadata over their other competitors as well. Okay, so this is the geek slide. Technologies, what we use for all of these things. So we have a single cluster. I can explain you afterwards if you'd like why we chose a single cluster deployment and not like separated it for development and testing, a different cluster for everything. Because many people say, well, what? You just run your development environment and your production together? What happens if one chokes the other or something? So we had our considerations for it. At first we started using Yarn. Do you know Yarn? Okay, great. It's a resource manager eventually. But after I think a couple of months we ditched it because we didn't use anything except of Spark. So we didn't need to share any resources with any like other Hadoop framework, Hive, or something else. All of our development and testing, live staging, and production environment ran on the same cluster, and we had many things that communicated with all of this ecosystem. Let's say Jenkins was our like orchestration and management over things. We had like a RESTful API Java services. You can take the analogy of Spring. If you know Spring, it's mostly like Spring. It's an open source framework that was developed by a company named Outbrain in Israel. And Node.js and Angular, I think it's common. You've probably heard of it even if you're not a full stack or a front-end developers. And we've used it to save it in different kinds of persistence layers as well. Okay, so what was our problem? We've talked a bit about the kind of data that we've had. But let's take a concrete problem that we ran into. We started off using Spark with a really small deployment. I think it was 5 nodes. It's really nothing. Really simple servers, I think with 4 CPUs each. And once we started off using Spark, we've got great power and tried to do many things. Okay, so the first persistency layer that we saved things was MongoDB, and with 5 nodes it worked great. Okay, with a really low amount of data, it worked and everything clicked and everything was fine. But once with great power and great data comes hunger, and we started off using with many more Spark nodes. We've grew I think to 30 or 40 nodes and more with all of our development and testing and staging environments, and started off overloading MongoDB as well. Okay, so as we've talked about the layers of analytics that we formed, each one of them was a microservice, a Spark application, a batch job that ran for a certain amount of time. And it varied between 10 minutes and 60 minutes, and even if we do a bootstrap process, it could go up to a couple of hours as well. And the biggest problem that we've encountered was trying to push 9 million requests per batch job, because we did some kind of computation that took, I don't know, 5 minutes, and the output of that was like around 9 million entities that I needed to push in some kind of persistence layer. So eventually we began with reads. The reads were from S3, computated some things, and the output was needed to push in some kind of indexed environment. And of course, the end was writes. Okay, why did we need to put it inside of a kind of indexed environment? Because we had clients that needed a single data point. Okay, I want to show in the UI which kind of problematic, I don't know, geolocation did some kind of different kind of computation. Okay, and I can't like read a 300 megabyte file each time to search for that single data point. So you need indexing, serving the data for other services and clients in the system. So this is like the basic deployment that we've had. And I think it's really common. And how many of you use MongoDB? Okay, so you know most of the times the best practice is to do a replica set, to protect your data and to be available and yada yada, but you have the master. The master replicates it to the slaves, and eventually you have multiple Spark workers. It doesn't really matter if it's different servers or a couple of workers on a single server, because we did multiple kinds of deployments, but eventually you write to the master. Okay, so this is the bottleneck of everything. And then it replicates and then reads and etc. etc. And these were the specs of the servers of, let's say, the R3 extra large, for those of you that are using Amazon. 4 CPUs, 300.5 gigabytes. I don't know why it's in half. Okay, I can't explain that. I really don't know. The storage was ephemeral. So the thing is that it was SSDs, okay, eventually. It doesn't really matter what ephemeral means, but the amount was 10 plus. Okay, it depended on the workload that we needed to run. And the MongoDB server was not that like weak, okay? It was in an older version, because the story I'm telling was around a year and a half ago, and this was like cutting edge, 2.6. After version 3, they've changed it to wire tiger storage, and it's supposed to be super efficient, not locking on databases, and etc. etc. But 4 CPUs, 15 gigabytes of memory, EBS drives are rotational drives, and the database size, the specific database that we wrote, the 9 million records each batch job, was around 500 gigabytes. It's not small, but it's not like big data scale. And we had 5 indices, and 4 of them were compound for like a couple of properties. So, what was the problem? A batch job should run 5 to 10 minutes, and the actual happened that it took like 40 minutes to run each time. And the computation wasn't the problem, because you have like a distributed tool like Spark. Why did it take 40 minutes? So at first, if any of you using Mongo, we've written all of the data unacknowledged. Okay, it's not safe, but again, it gives you better throughput. And with unacknowledged, it was asynchronous, and it took 20 minutes to write all of the messages, and 20 more minutes to analyze everything and to flush the journal. I'm sorry. It's like an uplog of MongoDB. So it's not really reasonable to run a batch job for 5 minutes to 10 minutes, and for it to take 40 minutes. And again, when all of this happened, the UI wasn't serving at all. Okay, you would get timeouts of everything, and the user just can't use the system. So this can't work. Okay, we thought of many alternative solutions. Okay, and why did we need to solve it so fast? Because we had some kind of like big maritime conference 3 weeks ahead, and we needed some kind of solution. Okay, the get-go, if this didn't work, was to cache everything and to serve stale data. But we actually solved it, so it was good. And a great feature of MongoDB, sharding. How many of you use sharding in MongoDB? You don't use it. It's really, really hard, okay? There are some pros, because you can enhance the throughput of MongoDB if you do sharding. Okay, the same like Cassandra nodes, which shard the data between of them. The same works for sharding keys in MongoDB. Okay, it increases the availability of the database, because you get certain data from different servers, so you get more availability. And the cons, DevOps is hell doing so. Okay, when you need to do resharding and introduce more nodes and to scale out, it's really, really hard. Things fail, okay? And the high cost of servers. Because of what we've talked about before, the best practice of Mongo of replicating everything 3 times, then you need 3 times the servers for each shard, and it's hell. Okay? So eventually it will look something like this. You have M workers of Spark, and you have lots and lots of sharded Mongos. Okay? And each time you need to reshard and you need to introduce more location for your data, you need to add more and more servers. Okay? On Amazon, it's costly. Each one of these servers individually is maybe cheap, but when you need to do an operation of, I don't know, hundreds of servers maybe for data, it's costly. So this is probably how a DevOps guy would look if we needed to manage everything, and I'll tell you a secret, we didn't have a DevOps guy. So it was between me and another team leader that we've divided the DevOps things. It wasn't fun. Another possibility, how many of you have heard of DynamoDB? Great. I just heard of the buzzword, the name. It's a KeyValueStore stored in Amazon. It's a service, and eventually it's supposed to be like a Cassandra equivalent. Okay, but again, it's a self-managed service. It costs more than actual servers, of course, like everything. And it maybe saves up DevOps, and you don't need to manage anything. But again, in that period, we thought for the future, and maybe we will need eventually like multi-data center replication, and then it didn't support it. It's not the real reason, but it was like another con that did minus to that solution. Again, it's a Catholic wedding to Amazon, because then you can't migrate the data if it's really, really large scale. It's really hard doing so with Cassandra as well, but again, I'm not vendor locked. And not enough use cases. I haven't heard any of my friends that actually use that. And then when I need to ask somebody when I have the problem, and the problem will occur, I won't have anybody to ask. And again, high cost of service. So another alternative solution was Apache Cassandra. It has a really large developer community. Maybe not locally in every place in the world, but again, you can ask people online, you have many resources. It's supposed to be a linearly scalable database, and it is, but again, you need to point out that it's not that easy to scale linearly anything. So take that in account. And again, it's not a single master architecture. Okay, this is a really important thing, because if a node dies and it's a master, it doesn't mess up my data and it doesn't mess up my workflow. You can just keep on working and everything works fine. And it's proven working with Spark. Okay, I don't need any more proof, because many people use it. So many people don't do mistakes, and if they do, I mistake with them. It's okay. And cons, of course, we don't have any experience with that database at all. Nobody knew it in the company, and we didn't have geospatial index, because it was really important for us to query like geospatial anomalies. We've managed to implement something ourselves over Cassandra. I explained it briefly beforehand. If somebody is interested in that, I can explain it as well later. Okay, so the solution. We did a migration in steps. At first, we started off with writing the bad jobs. It took more time, of course, as you understand, both simultaneously to Cassandra and to MongoDB, just to see the performance of both of them. Okay, so we collected metrics over it, and we tried off all of the possibilities. We started off with using the DataStax community AMI. AMI is like a computer image on Amazon. Okay, you just pour an image over a machine, connect it to different to other nodes, other Cassandra nodes, and everything just clicks. Okay, yeah, I know it's not that seamless. Even DataStax doesn't recommend to put it in production and everything, but it works. It works from, I don't know, at least for the first month or so, you can work with it, and it's amazing. But again, when you need to tune it and you need to go into the internals, it just doesn't scale. Okay? And first easy steps, we use the Cassandra DataStax connector. Okay, sorry, Spark Cassandra connector. It is sponsored by DataStax, and they develop it, and it's open source, and you can use it. It's really great, again, for the first ramp up to read all of the data, digest it, and do all of the transformations in memory. But the thing is that once you need optimization, okay, and going in depth in the internals, it just doesn't work as well, okay? And we started off using later on with CQL. which is the de facto way to work with Cassandra. Okay, and a really important thing, monitoring. Okay, monitoring. You need to, it's a distributed environment, and once you don't have monitoring, you're like flying blind. Okay, so one of the implementations and one of the things that we've put our focus on is monitoring Cassandra. I will talk about it a bit later. Okay, so how did it look after the first deployment? You have a Cassandra cluster, okay, with several nodes. The first deployment was 3 nodes, okay, it was modest. And then all of the workers worked in front of the Cassandra cluster that we created. All of the environments worked, again, on a single cluster in different, what's called key spaces. If you know from other databases, it's a database, actual database, and all of the indices and everything is combined into a single key space. So this gave us the availability for the serving, okay? For serving the clients, for serving other services as well, and of course improve the availability of the database as well. So let's have numbers. It's much easier to show examples, real life examples. So we started off with 40 minutes writes in MongoDB and downscaled it to 3 minutes, okay? I don't remember the exact amount of data that was held in 9 million records, but again, we can see it's orders of magnitude less. How much time did it take? This is the important thing. From 0 to hero, from having nothing to forming an operational cluster and something that did work in the conference, it took around 2 weeks, okay? 2 weeks with the actual infrastructure of Cassandra and writing the code and integrating the code to write all the things. Again, it depends on the software, yeah?
How many people worked on that?
Hello.
Wow.
Okay. Yeah, it was a side project that I needed to work on, and the thing is that it works. Again, not as an operational project, and I'm not saying I'm genius and I'm a good coder or anything. It's pretty simple. It's really easy, okay? Again, from 0 to hero. But afterwards, you encounter lots and lots of different kind of problems, especially when you want to scale things, especially when you want to add more data, and when you want to go in depth into the performance side. Yeah.
What about backups? You do backups in those 2 weeks?
The answer is no. We didn't do any backups because the replication model of Cassandra should take, part of that thing of backups. The same as Hadoop. You don't back up your Hadoop cluster, okay?
But
your HDFS.
But you might corrupt your data unintentionally.
Exactly. Exactly. So the question should be, what's your single source of truth? And not, do I back up Cassandra? The thing is that we've taken a different kind of approach, okay? My single source of truth was F3, okay? And I could, in a certain cost and certain amount of time, recreate the Cassandra cluster, okay? So I can take the bad job, read the data, and rewrite the data to Cassandra in a manner of corruption. And I corrupted the data at least 3 or 4 times until something was really operational afterwards. But for the conference, for what needed to work, it did the job. Okay? I've heard of people trying to replicate, to back up Cassandra. You have incremental snapshots, it's a feature of Cassandra, and you can back up all of that data somewhere, I don't know. But let's say you have a 10 terabyte cluster, which it's not a big cluster, it's a fair cluster, I can say. How do you back up 10 terabytes, network-wise or storage-wise? You just need to rely on the replication. Okay?
Can you answer this question?
What?
Can you answer your question?
How do you back up it?
If you get terabytes of data,
Do I back up?
backups?
Not to a database like Cassandra, in my opinion. Maybe there are people that do so. I don't know. I won't say it's right, but I don't believe it's right to back up things, because if you back up, you need to restore the thing. So how much time will it take to restore all the data? If it's seamless and it will take 5 minutes, okay, back everything up if you're like a banking transactional system. But if it takes me, I don't know, a day, okay, to take all the backups, is it good enough? I don't know. Every business
You can
for,
back afterwards.
of course, no problem. Okay, it was a running solution with almost no glitches, and do you know how can I prove it that it was a working solution? During one of the days of the conference, we had a time gap. It was in Singapore, I think, and we were in Israel. So when they started off the conference, we were asleep. Okay, so one of the nodes died during the night because of, I don't know, some thing that I've done in the code. Okay, the system was operational. Okay, the data was served, and we didn't lose any data because only one node out of 3 died. If another node would have died, it would probably cause catastrophe. But still, it did work. And usually you don't deploy a cluster production like of 3 nodes. You need more applications and you need to scale it out. Okay, so we solved the problem, right? Not exactly. And this was up to the conference and everything worked well. But again, as I said, you have many more problems that will come in time. Cassandra will work well and it will be like a great database, sub-millisecond, blah, 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 response time, up until 2 weeks. And then when maintenance needs to happen and you don't do that, you screw up. Then you need to encounter different kinds of problems, okay? And the latency grows and rises all the time. And eventually you can get in many, many problems. Afterwards, of course, with the possibilities that we introduced with Cassandra, came more hunger for data. And we started off using our big entity resolution process as well and trying to write it to Cassandra too. Okay, and to form the data pipeline over Cassandra. It should work, okay? Should doesn't work. And the thing is that we had a process that needed to run every 10 minutes, like exactly 10 minutes, and we needed to write 30 gigabytes of data into somewhere, okay? It's a lot. It's not like Google scale, but it's a lot. And with a replication factor of 3, it becomes 90 gigabytes. Okay, only network-wise, it's really, really hard. At first, to Cassandra, it took around 80 minutes only to write the data. Okay, again, it doesn't work in a 10-minute time slot, not acceptable. Do any of you know Ops Center, the monitoring solution that comes with data stacks? So this is the dashboard. You can see it was a 16-node cluster. The nodes were pretty large, okay? It had, I think, 8 CPUs, really, really large, 1.6 terabyte SSD drives, and it had 60-something gigabytes of memory. So it's not small servers, but you can see this was before everything started to die. When everything becomes red, right afterwards nodes just die, and they become gray, and that's it. You just start losing data, losing all of your operations over the cluster, and that's not good. Okay? So what were the solutions? And this started off a process of around 2.5, 3 months. Okay? Which we started off tuning. I consulted with some of the guys at DataStax and iterated over things, found blog posts, did many, many things. We can point them out. First, we chose the i2 extra large instances, tuned them and optimized them to fit the cluster. Everything, of course, is running in the cloud, okay? It's not on-prem data centers. Changing the JDK to Java 8 did wonders, okay? We changed the GC algorithm to G1. How many are you Java developers? Go Team Java. It does amazing things because the G1 garbage collection does wonders. I wrote a blog post in the blog, if you'd like, of explanation of why and what and how to tune that. We tuned the operation system as well. Removed the, increased the U limits, removing the swap. Okay, removing the swap can kill your server, but it never happened until now, I think. And write time went down from 18 minutes to all the amount of data that we've talked about to 5 minutes. Okay, is it good? Process of 10 minutes, downscaling it to 5 minutes. Pretty much, okay? And the people that I've consulted with, even in DataStax, told me that it was great and the performance to that amount of data is good, but it wasn't good enough. And you can see this is CloudWatch, the monitoring solution from Amazon. And you can see the I/O operations are probably maxed. And the CPU utilization is like around the 100% when we did that solution, when it downscaled to 5 minutes. So it's good, but it's not good enough, and it doesn't provide us the solution that we like, because if you have a really small hiccup of the writing, you can just like go over the 10-minute limit and you will have a problem of latency over your whole data pipeline. So we took the same model that we had in Cassandra and using the partition keys and everything and the same data modeling and applied it to S3 because S3 is supposed to be much more scalable and much more appropriate to the Spark servers. By the way, we were writing with simultaneously with 100 servers, around 100 servers, writing to Cassandra. Okay, so once we switched off only that kind of process into S3, we downscaled it to 1.5 minutes of write. Okay, and this is again orders of magnitude better than the 18 minutes that we started off in the beginning. Okay, and again, we added that kind of process to our main process, and we've added a detached process which indexed all of the data. Once in 15 minutes, this is the latency that we can like introduce to the data. Every 15 minutes, there was a process that read all of the information from S3, downscaled the data, and why downscale the data? Because a ship might report in a single straight line multiple data points, but all I care about is A and B, the beginning and the finish. I don't care about all of the points in the middle. So this is like downscaling the data, and this is what improved the performance, both with writing the same amount of data that I wanted in the beginning and downscaling the data. Again, this is what the solution looked like. We had the parse raw data, analytics via Spark, and we started writing the data into different locations, different persistency layers. And because of that, I will never say what is the best database in the world, because there is none. Okay? There is the appropriate solution for each problem. And each problem was solved with a different kind of database. For the staging data and the aggregated data, MongoDB did wonders. It had indexing, it had great things. For the heavy data fusion process that we've introduced in the last slide, we had S3. And for the downscale data, the index data that needed to be served into the client, we had Cassandra, of course. And everybody was happy. Almost happy. Okay. So this is mostly about the use case, but let's talk about some kind of, winners tips that we can introduce to the newbies that want to start off using Cassandra and to have much easier way in. At first, you can use, this is Java code, by the way, all of the code that we wrote, almost all of the code, 8% was in Java, some of it was in Scala. And it's a regular connection that you open up to with the CQL connection. Use token-aware policy, okay? What token-aware policy means, and I really don't know why it's not the default, okay? What it means that it hashes the partition key in the client side. And instead of going into some coordinator node and then him hopping back to you and telling you the data is in a different node, you just go to the specific node where the data lies at and just access it. It does amazing improvement in performance, okay? Because it's not only the order of magnitude of one of hopping to a different one, you just don't overload the network. And when you need to do a bulk insert of so many entities, you overload the network more than the actual throughput that you need to invest into writing things. Okay, monitoring. I've mentioned it before, and I can't say enough times, you need to monitor everything, okay? Both the Cassandra metrics, the JVM metrics, the OS metrics of the servers that Cassandra relies on, okay? Collect everything and just feature flag everything, okay? Not always you need to just send everything to the monitoring solution because you will kill it as well. I did that as well. I killed Graphite multiple times with metrics from Cassandra. How do you do that? Okay, so I've mentioned it's important. So you have multiple solutions, of course. You have the Ops Center by DataStax. Okay, this is an open source tool that you can install even without, paying lots of money, and it gives you a lot of value from the get-go. But it has its own limitations as well, because if you want to be flexible and add your own metrics, it's not a multi-dimensional monitoring solution. It gives you the metrics of Cassandra, and it does that really, really well. Okay. So you can read my blog post as well about the solution that we've made, or multiple solutions that we've made to monitoring Cassandra. By the way, I will send you the slides afterwards, so don't worry. And the plug-and-play metrics that we've implemented, it's a Java process, okay? So you can add things to the class path of Cassandra. And one of them is the metrics library, each metrics library that you like that can connect to JMX. I used, I think, Drop Wizard's metrics library. And the thing is that it reports back to wherever you want. You can put any sync of data for the metrics library. We've used Graphite. Okay, so it sends all the packets to Graphite. Of course, not only like the fancy GUI things, you have the regular things, the regular Linux tools. By the way, how many of you are Linux users in production? Great, continue. And the thing is that you can use dstat, iostat, iotop, and jstack, all of the regular tools that will give you the metrics per node. Okay, it won't give you cross-cluster, but when you have a flaky node or some kind of node that does kind of problems, these are great tools that will give you insights instantaneously. Okay, even I think the DataStax Ops Center uses most of these tools to give you some of the metrics from the internals. A graphics is always good. You can see a Cassandra cluster reporting, first of all, from the DataStax agents, the green ones, to the Ops Center, and the Graphite like inner metrics library reported to Graphite and showed everything via Graphite. Of course, we've encountered problems there too. Okay, as I said before, I think Cassandra has internally around 8 million metrics. Once you report everything and you don't apply filters, you kill Graphite. That's what happens. Okay, and your monitoring problem becomes a big data problem itself. So you don't do that, but if you do want to do that for some kind of reason, you have other kinds of implementations you can apply. First of all is like InfluxDB. Okay, it's a time series database written also in C++. It's pretty good, but it has its own problems as well. Okay, once you need to do sharding with it, you need to pay. Okay, they do break their own versions because version I think 0.19 was different from 0.20 or something, or 0.18.5 just broke all of the contracts. So it's pretty hard. You have other kinds of solutions. Any of you heard of Prometheus by SoundCloud? Another monitoring solution, a great one, but it takes a different kind of approach. All of these solutions are push-based. You push metrics to your monitoring solution. Prometheus works from the other way around. It pulls things, okay? So you just open it up for scraping and you need to pull things. I have some blog posts of a different company in Israel, Outbrain, that actually implemented some kind of wrapper over Prometheus, which like monitors Cassandra. I can point you out to that as well if you're interested in it. This is how it looks. Okay, the great thing about Graphite and Grafana, which we don't have on Ops Center, is that I can cross OS and infrastructure metrics with my own application metrics. As I report things from Cassandra and from the operation system, I can report business logic things as well. Okay, I did the transaction named, I don't know, whatever, and this correlates with the graphs of the infrastructure. So if I have some kind of peak of CPU for 100%, I know what actually caused that. What business logic in my system caused that. And it's really, really important. Okay, so we added lots of inner metrics. Of course, it gives you the overhead of instrumenting all of your things. Okay, so every transaction, every opening connection, every insert should be monitored. But it should be monitored anyway. So it's a lot of work for a good thing. CQL driver. Again, we started off using the DataStax connector, the Spark DataStax connector. It was great until a certain point. And when we needed like to scale things our way, and we didn't want to write and read everything, the CQL driver did wonders. Okay, I could filter things that I don't want to influence the database, because everybody says just write everything to Cassandra. It does wonders. It takes it well. It has a great throughput. But the thing is that every write introduces much more garbage to Cassandra and much more administration in the background. And once it needs to do many operations in the back, the performance is downgraded. Okay? So if I don't need to write the entity, I just won't write it. And I won't introduce a new tombstone or a new bad thing that Cassandra needs to manage. Okay. Applying actions, every action that I apply, every open connection, I should monitor that. Okay, I should report that because maybe I'm opening more connections than I'm closing. Okay, and then I have like zombie processes that open connections to Cassandra and then I time out. Insert, selects, updates, deletes, everything. Yes, monitor everything. Okay, because it's much easier to filter out things than to try to instrument things from the inside, and I don't like going back to code that I wrote. Okay, better that just leave it working. And again, how do we monitor anything? Counting, execution times, errors, and everything from the infrastructure that I can give. It just gives us better visibility over our cluster. Okay, and why SQL queries are better? Because once we get to know our data model better, okay, just reading everything in a bulk is not that good, okay? And you're better off using incremental writes and reads for specific data. And again, you can use many more features of SQL, batch jobs, like batch queries. Don't use it to optimize, use it for like lightweight transactions. And you have a feature of lightweight transactions in your Cassandra versions as well. And you have prepared statements that you can reuse, and it gains much more performance than regular statements that you generate yourself. And do any of you know NoTool? Okay, this is like the administration tool of Cassandra. It's per node, of course, but you can you can introduce actions to every single node. The DataStax Enterprise edition gives you all the functionality of NoTool that you need to do manually from the administration of Ops Center. So you have the gains. It just depends on what you need and what you prefer using. And know your queries and know your model before you start off using Cassandra. It's not like MongoDB that everything is flexible and you can just shift things, move things, and change. It's really rigid. Okay, you need to know to ask the questions of what actually do I need to read and write and how before you start implementing things. Because after you have a really large-scale database, migrating it is really, really painful. Okay, again, we've talked about dashboards, so you have the Dev Center that we've talked about, but you have some kind of tool that you'd like to connect to the database, right? How many of you using like desktop clients or web clients to your databases? MongoDB, what are you using? RoboMongo, yeah. It works well. It works well. Your versions are really good, but what do you have for Cassandra? Okay, question mark. That was the same question mark I had. Most of the people told me, oh, just open up like a SQL shell. Okay, no. I want something much more comfortable and not opening it to a specific node. And I found a pretty good tool, pretty decent tool called dbeaver. Okay, it connects to multiple databases, to MongoDB as well, to relational databases, even to DB2. Any of you using mainframe? I don't know why, but okay. It's a pretty great tool. It's open source, and if you want to use that, download the Enterprise Edition because this is the only one that supports NoSQL, and it's paid. It's free as well. I don't know why do they call that Enterprise, but whatever. And another open source tool, and a great tool that was developed by some startup company in Israel that when they closed the company, they just released everything through open source. And it's called Redash. It's a dashboard, like a web application, which connects to different kinds of data sources. Okay, it can connect to MongoDB, to relational databases, from the newer version to Cassandra and different kinds of equivalents. And you can see all of the things that you'd like in a single dashboard. Yeah.
Question. Which of those tools do you think is the best? Because I'm
All of
using
them.
the Dev Center, but maybe, and it's sufficient, or I should
You're
try
using the Dev
more?
Center for monitoring, right?
Yeah. Also for making queries.
For queries, really? Interesting.
So did you? I think that you confused the Dev Center with Ops Center. So the Ops Center is for monitoring, but Dev Center is for writing
you're
queries.
right. You're right. I haven't used Dev Center for a long time. Yeah, sorry. You are right. Okay, you are right. I'm wrong. But the Dev Center is really minimal. Okay, you can use that. It's great, but it's like a fork, I think, from Eclipse. From some kind, it works the same way, and it's pretty minimal. Okay, if it works for you, just use it. I won't say what's better because it works for you. gives you all the functionality that you need, it's okay. But the thing that annoyed me in Dev Center that you needed to refresh everything once you've changed something in the definition of tables. So you needed to disconnect and connect. It was, I'm talking about a year and a half ago, I don't know right now. But try altering the table. If it shows up and refreshes, probably they've updated it. But
Yeah, I think they updated.
probably, but again, I'm talking about a year and a half ago, okay? Almost a year and a half. And again, redash works as well. Just pick a tool. Pick a tool, something that is convenient for you. Okay. For the conclusions. Cassandra is a great database. It's linearly scalable. It can like move data and introduce new nodes, but you need to follow the best practices, okay? And sometimes it won't be as optimal as you thought of because you need to leave, let's say, storage-wise, okay? You need to leave Cassandra up to 50% utilization of your storage, because if you overlap that barrier, the thing with that the things that it does in the background will eventually be slower and slower and start failing. When you need to introduce new nodes, okay, you need to introduce new nodes. What does it mean? Resharding will happen, okay? Data will move through across your cluster. And if a node holds 800 gigabytes, then you're probably screwed, okay? Replication and introducing a new node might take even a day. And network, okay? How many of you know on which bandwidth network are you running at? 1 gigabyte, 10 gigabytes. How many of you know that? Great. How much?
3
How much bandwidth do you have in your network? 1 gig, 10 gig?
for 1 week or overall?
No, overall. It's a bandwidth
10 gigabytes.
10 gigabytes. 10 gigabytes is good, but if you have 1 gigabyte and you have lots of nodes, then we will have lots of timeouts in Cassandra. Okay, introducing new nodes will be really, really hard. Most of the people, most of the developers don't know that and don't care. Okay, because it's not important, but it does really degrade your performance if you don't have a really fast network. The gossip protocol that Cassandra works on, okay, relies solely on network. And if you have slow networks, and what happens in Amazon if you take the cheaper instances, you automatically get a crappy network, okay, moderate and slow network, and then you just happen to have many problems. And you said Cassandra is linearly scalable. You said it's a great database. Why do I have problems? This is the reason, okay? Because the underlying infrastructure is crap. And monitor as much as you can. Really, just try to visualize everything and try to alert everything, because this is what will give you the best visualization of what's happening in the environment. Data modeling is key to success for everything. Okay, it's not a really flexible database. You can do many things, but you need to know how you query your data and what's your data. If you don't know that, you will run into many, many problems. And be ready for your next war. This is one of the Zen things that I will say. But again, you will need to introduce yourself to Cassandra tuning. Always. It depends on your hardware, it depends on your workload, and be ready to go inside the internals if you'd like to get great performance from Cassandra. Okay? It's not seamless. It just doesn't work magically, okay? Okay. I've talked, I think, for about 50 minutes. Probably your faces are like this. Okay, so, yeah.
My first question is, how did you implement
Geospatial index. Okay. How do we implement the geospatial index? Was the question. The thing is that you can introduce things to your key in Cassandra. You know Cassandra a bit? Okay, so I will throw phrases. If you don't understand, just say. You have the partition key and you have the clustering key. So in everything, you can add more properties. Okay. The partition key says in which node it goes, the data goes, and you have like a tree index over the clustering key. We've introduced new properties, new synthetic properties over a geospatial location, like the confining square of a certain point. Okay, and you can do in each resolution that you like. You can like build something that is called an R tree memory with layers and everything. And if you have like a certain cell in the world that has lots of data and other cells don't have lots of data, you can downscale the square sizes. But again, you introduce new properties, and then when you query, you can filter over these things. Okay, so I say, give me things from the cell of whatever in a certain size, and then when I get all of the data, I can filter it in memory. So it doesn't give me the pinpoint data structure that MongoDB might give me, but again, in batch jobs that run in several minutes, I don't care. I will just read the data, digest it, and introduce new features into Cassandra. I know that in DataStax Enterprise, they might introduce the geospatial index to the search index to do the geospatial index or things like it, but I've never used it, so I can't say anything smart about it. Yeah.
You mentioned before that introducing new nodes might be actually nightmare.
Mm-hmm.
And in which moments actually you introduce them? Because basically replicating hundreds of gigabytes of data might be nightmare.
I know.
I agree. But you don't know that you need more and more nodes until a certain point.
Right.
So how do you avoid
How do
this
you know?
situation?
First question. Okay. How do you know when you need to scale up your cluster? Monitoring is the answer.
Yeah.
Okay. Once you monitor and alert your disks, you know that you're like going over a certain threshold of 50%. You need to introduce new nodes. I will say even 40. Okay. But how many nodes?
Yeah.
This is the other question, and how do you do that? You should do it incrementally. You don't like introduce 2 times the cluster. You just add nodes incrementally, and each time you introduce new nodes, you get like respread of your key space. Okay, so key space not meaning it means like more the key range is the more correct phrase. And once you introduce the new node, some of the keys just lay there irrelevant. Okay, so what happens? You need to do a process called cleanup afterwards. But what I usually did, I introduced several nodes, not only one, and then I just did cleanup over all of the other nodes that held irrelevant keys. And then you just downscale your whole capacity, right?
Yeah, but just all the resharding, I would say, takes
This
time.
happens, yeah, this happens automatically, but if you keep your disks, let's say, less than 100 gigabytes, meaning the capacity of a node, let's say, should be 200 gigabytes, and you keep your nodes small enough, like meaning you have only 80 gigabytes, 90 gigabytes in capacity, then this whole replication will be really easy. I've asked the same question of one of the engineers at Netflix, El Toby, if you know him. He's an amazing guy, really. I've read his blog post. It could have saved me 3 months of my life if I'd read it before. And he told me that Netflix, they just underutilize their own nodes because they have Chaos Monkey that always kills nodes. And all of this resharding happens all of the time. So new nodes being introduced is not something irregular. But again, I'm not Netflix, so yeah.
Did you run some additional maintenance processes to keep Cassandra
Alive?
performance high? To keep its performance high.
Okay, the question was, did I run any maintenance, special maintenance things to keep the Cassandra performance? First of all,
schedule it in a
you need to run repairs all the time. You have a cap, I think, of 10 days by default that it should run repairs, just run it more, okay? Not every 10 days, because it should be, again, one of the operational things that happen in the background. To monitor the latency, you can introduce like latency checks that you write yourself. Even in Jenkins and with regular JUnits, run a scheduled job that just queries something and gets back. And if a certain amount of the latency is introduced, let's say 100 milliseconds is my cap. If I go over that, alert that min. Okay, see what's the problem. Try tracing back to the monitoring solution and try checking what's the problem. These are the background things that should happen. But again, once you introduce something and you do it manually at least 2 times, the 3rd time try doing it automatically. This is my best tip that I can give you. Because if not, there will be a guy really sad in your company. He will be the guy in charge of it. So it's really unfun. You had a question, Joe?
Yeah. So have you tried using Cassandra 3.0? or
No.
the newer version?
No,
Because it has a new storage engine, so I think that it would improve a lot your throughput for writing.
okay. Two things. First, I don't work at the company anymore, so I can't use it. But I do agree. Cassandra 3.0 and on has new features. But the thing is that the newest version then was Cassandra 2.17, even not 2.2. So I know everything is improving and everything is changing. And if you've talked about versioning, I will say another word about it. Try doing all of the deployments and implementations as much as like immutable as you can, and try doing it automatically. If you're using something like Chef, Puppet, Ansible, Salt Stack, whatever, try automating everything. Okay, so if a new version of Cassandra comes out, and it will happen all the time, that deploying the new cluster won't be a hazard. Okay, and you won't be afraid of doing so because the engineer that worked a year and a half ago just left and nobody knows how to, I don't know, do anything with Cassandra. This is crap, okay? It will make your life much, much harder if you don't automate anything. Even the checks, even the cleanups, even the, I don't know, the maintenance things, once you do it manually, okay, you will start crying at night. So there was, yeah.
How about consistency? Because as far as I know, Mongo is, in terms of cap CRM, is CV solution, and Cassandra is AP, right?
Okay. First of all, Cassandra has what's called tunable consistency. Okay? You can eventually do each query however you want. You can do it fully consistent, but it will most of the time fail. Okay? That's the thing. You can do what's called consistency all, and it needs to like replicate it across all of the clusters in the replication factors that you've defined, and it needs to get acknowledged of writes. But the thing is that you have things in the middle. Okay, what's called quorum, that most of the nodes replicated, and it's okay because they will replicate eventually. Okay, and you have local quorum, which means a quorum in your own data center, and then to the other data center in a different place, it will replicate it eventually. Okay, even in Mongo, it's only a matter of latency. Like eventually when you lock things. Okay, in Cassandra you can do the same, but again, it's not preferable to do so. Okay, and usually you can do, if your code is what's called idempotent, you don't care, because you can do things over and over again in manner of failure, and it works. But again, this is changing the way you code more than changing the way you work with your infrastructure. And once you have like vast amounts of data, okay, the cap theorem doesn't work. Or you just pay a lot of money and buy Vertica or something. That works as well for some people. But again, that will like cap out in a certain amount of memory or like storage. So try solving it around, and Cassandra can give you the tools to do so. But again, it depends on the developer. How do you develop your code? Okay. Yes, another question.
What about actually the framework which you use to migrate from Mongo to Cassandra? Is it
What's your name?
Philip.
Philip. It's called Philip.
Ah, okay.
It's you. It's mostly you, because you need to read all of the data. No.
I will need my
Everybody Philip will help me. No, I'm just kidding. You should implement it at first yourself, but the thing is that both of them are storage engines. Okay, so you need something to digest the data and to write it back. If you do it sequentially in, I don't know, a Java process or a Python process, it just won't scale, it won't work, because you need to read terabytes of data. Okay, so for that we've used Spark. Spark is our computation framework, and this is the supplementary thing to the NoSQL world, because it reduces joins, it reduces operations to the NoSQL world. It doesn't really matter which database, because Mongo is a NoSQL database, Cassandra is a NoSQL database. You have many more like solutions of that kind. But again, you need to digest the data, you need to read it, and then you need to just write it back to somewhere. So if it's the question, the framework was Spark. Okay, but you can use other distributed tools to do so. Okay, I'll leave some resources. First of all, thank you for having me. It was really great meeting you. be as available as I can, so you can like take any account of social media that you'd like to ask questions. LinkedIn, Twitter, you have my blog there, personal email. You can, like, I don't know, send me a postal pigeon if you'd like, if you do get alive to Israel. And these are the links for the big data community that I'm running. It's called Big Things. We are on Facebook. We have our own YouTube channel that we record all of the sessions. Which one of them are in English? You can use them as well. In Hebrew, you might want to learn Hebrew, I don't know. And I run another community that is called Cloud GDG, more about cloud service providers. GDG is a global developer group. Again, whatever you'd like, I will try to answer your questions in my own capacity. And thank you very much again. Thank you.